One of the most compelling yet often neglected aspects of aging as malnutrition lies in the liver's diminishing ability to detoxify endogenous and environmental toxins, a decline frequently interpreted as a hallmark of senescence. The liver's detoxification system operates in two phases. Phase 1, enzymes chemically modify toxins, often generating reactive intermediates, while Phase 2 enzymes conjugate these intermediates to make them water-soluble and ready for excretion. Central to Phase 2 detoxification is the synthesis of glutathione, the body's master antioxidant and detoxifier, which depends on a steady supply of sulfur-containing amino acids, primarily cysteine, along with glycine and glutamate. Cysteine availability is almost always the rate-limiting step in glutathione production, as it supplies the critical sulfhydryl SH groups that give glutathione its powerful antioxidant and conjugating capabilities. Diets chronically low in high-quality protein sources, particularly those rich in sulfur amino acids such as eggs, fish, poultry, and legumes, lead to suboptimal cysteine intake. This inadequacy compromises the liver's ability to produce sufficient glutathione, leaving cells vulnerable to oxidative stress and impairing the body's ability to neutralize and eliminate toxins ranging from heavy metals to lipid peroxidation byproducts. As a result, reactive intermediates and unmetabolized toxins accumulate in tissues, increasing cellular stress and damage. Over time, this toxic burden accelerates mitochondrial dysfunction, damages DNA, and promotes chronic inflammation, processes that collectively contribute to the cellular deterioration and tissue dysfunction often labeled as senescence. The buildup of such toxic metabolites can also disrupt signaling pathways critical for normal cell cycling and repair, pushing cells into a state of dysfunction or arrest that resembles aging at the cellular level. Compellingly, research shows that restoring sulfur amino acid intake, whether through dietary strategies or targeted supplementation, can replenish glutathione levels, enhance Phase 2 detoxification enzyme activity, and reduce oxidative and inflammatory markers even in older adults. In animal models, cysteine and glycine supplementation reverses age-related declines in glutathione synthesis, improves detoxification capacity, and preserves organ function. These findings suggest that what is commonly accepted as an unavoidable decline in detoxification with age is in fact a correctable deficit in sulfur amino acid nutrition. Moreover, populations consuming traditional diets with sufficient high-quality protein sources maintain more robust glutathione levels and better detoxification profiles well into old age, correlating with lower rates of chronic diseases linked to toxin accumulation, such as neurodegenerative disorders and certain cancers. Conversely, modern diets relying heavily on ultra-processed, low-protein foods contribute to widespread sulfur amino acid inadequacy, hastening glutathione depletion and the resulting toxic stress that accelerates tissue aging. By reframing impaired detoxification in aging as a predictable consequence of chronic undernourishment in sulfur amino acids rather than an intrinsic or genetically programmed degeneration, we open a practical, empowering pathway for intervention. Meeting lifelong protein needs, with a focus on foods rich in cysteine and other detox-supportive nutrients, can preserve the liver's detoxifying power, reduce the accumulation of cellular toxins, and support systemic resilience well into advanced age. Ultimately, recognizing declining detoxification capacity as a sign of subtle but reversible malnutrition provides yet another powerful layer of evidence for the thesis that aging reflects chronic nutritional inadequacy, not an inescapable disease. It highlights the profound potential of nutrition to protect cellular integrity, detoxify effectively, and maintain vitality throughout life.